Hello. Um, Second video. I've made second computer. It's not that much different. Just it's been adapted to 8 bits. Let's check it out. Fast. Oh yeah. Um, this is the computer. It has 3 digits as its display. Can display all the way up until 255. Um, that's that. That's there. Um, there we go. And you can jump. Um, this is the actual computer. Has the ROM for easy inputting. Same program counter, just it can jump further. And as you just saw, I'm doing the K key for jumping, but it's gonna be this that J key. See for jump. I don't think it does. You just gotta hold it for a while. This is the actual CPU. We have a bigger control unit with memory outputs. Um, ACM, ACC input. Other than that, it's the exact same. Um, except, oh wait, no, I forgot. There's these buses. They transport the data in a much cleaner way. So instead of the mess that was the other one, you just, it looks clean. We have a memory array. So with SR latches so that you can toggle which register you're reading from instead of turning on the next instruction it's not reading. Problem couldn't actually read from any instruction. So now it's a SR latch to save it. But I was like, well, whenever I update it, only ever turn it on. So I did these ORs to turn off an SR latch whenever normal is turned on. Saying, all right, we can turn on normal every time we have an input. Normal, then that. I remembered you can't do delays, at least not intentionally, without pulses. And that would kind of undermine part of how this works. So, I switched it to AND gates, have the normal still go in there, in case I ended up wanting to use it. And those AND gates have XOR gates. Well, the XOR gates take an input from normal and from these, one that actually goes into it, so that unless there's two, unless if normal is on and that's on, won't turn on. But if only one of them's on, it'll turn on. It'll activate this and, which will reset, but they will directly activate it. So it's essentially you're resetting all of them, but for the ones you don't want to reset, you glitch them. It's not the best system. These hands take clock. Mistake. They're in ORs for the XOR. So whenever any of these are on, all the ones that are on don't reset. That's what it was. This decoder goes into these ands, which have to be turned. No, these are the store functions. They have to be turned on by the SO latch to know which one you want to actually do. This is just for the reading. Sorry. You have 8 registers. There is no 0 register. It's 1 through 8. You have opcodes to make sure the bus doesn't glitch out. So that you only ever read one at a time. Currently, we're reading register 1, register 2. I don't know why that is. Strange. Oh, there is a 0 register. Didn't realize that. Um, the output, it's just a memory array. We have a mux right here, so we can take the input from the ACC register, because that was a problem in the last one. You can only ever add what was in instruction, which means to actually, like, let's say you wanted to add 3 plus 3 plus 3. You want to add, or not add, you wanted to multiply the ACC by 2. You would have to know what the ACC is, just magically. And then you would have to add it itself to it, in which there's no way to actually know unless it's a predetermined algorithm. Then we have the display register, of course, kind of like constantly updating for no reason. We have jumping, we have the conditions. This is the jump output, which makes it to where this bottom one can either be a number you store or the number you jump with. Just a little bit of um, optimization. This is the only change. These instead, yeah, there's a little bit better wiring. Other than that, nothing changed. Was gonna wire to the 4-bit LUs together, but the condition flags didn't work the best. I failed half the time like this computer already does. So I'm not trying to deal with that. I currently have a program to add 1 until it overflows. Then it will reset to 0, then start adding 2 until it reaches 255 and overflows. T flip-flop with J, or T flip-flop, so J, so I just, so that every clock tick, it has to click twice for it to be a clock tick to stay in sync with the program counter. Now, if we go into here, you'll see that I did a double dabble system. Crazy, I know, right? It's almost like that's the way you're supposed to do it. Made a double, then I doubled it, then I doubled it, then I almost doubled it. It's pretty much, I just lined them up so that it actually does the correct output. Goes all the way up until 255. I have these names right there, so for the display, you can see, oh, these are the ones, no, those are the tens, those are the hundreds. Makes it easier to wire up. You essentially counting in two base system in four base sets. Gotta see it. Switch over to the next bit. Um, and that'll be not very interesting. Not gonna try and over exaggerate it. It just stays there for a second. And you see one, two, three, four, five, or one, two, three, five. That's the system. It's gonna be a really short video. What else do I have to show? Oh yeah, example. Forgot to say all my changes. It's fine. This bit is fun. This, so I can continue counting without me making a whole new counter. Don't mind it. It's fine. I swear, it's fine. Um, it's a clock, but this is why it was running so quick at the start. This is the fastest I can get it to go. A lot running in the background. That's why. But it resets whenever it reaches 6, uh, 6, 5, 5, 3, 6. My headphones disconnected for some reason. But whenever it reaches that, it wraps back around to 0. Um, this pulse right here is so that you would only have a one tick pulse instead of the like 100 ticks it would normally be from this. So invert it, pulse, so that it's on the drop. So it's happens, turns off, turns back on with the next number. So it technically skips the tens, but it's fine. It works basically the same. It just means whenever you get big inputs into this, which I think is this digit, basically, like every 1.4 times that one changes, something like that. Can't tell if it's 1.5. I think it's a little less. It'll change. Um, it runs through the and check they're still all are on. And it turns off the knot, turns this off, which will then turn that off. But then this will update to be only have one on, so that will turn on. Or, yeah, so this turn. Sorry, my mouse is jacked up. Without a mouse, I gotta get a new one. Drop it one time. This then turn back on, sending a pulse to there, and it goes up by one. That could have been combined in less time than it took me to come up with this system. But I was being lazy, didn't want to open up a new tab. So, but that's it. That's the whole computer. I have essentially the same emulator as the 4-bit, slightly different for the instructions. It's like I can load, I have like a load number into register so and so and input. Um, I am signing off. See ya.